So eventually you're going to need to be taking the derivatives of the inverse trig functions. It's not asked on the AP exam hardly at all, but we're still going to do it. First of all, the trig functions don't actually have inverses as they stand, because formally for a function to have an inverse, let's go ahead and sketch this. For a function to have an inverse, first of all, it has to be a function, so it has to pass the vertical line test. But for its inverse to be a function, it would have to pass the horizontal line test. So we really say that they only have inverses if they're 1 to 1, which means there's only one x for every y and only one y for every x. And we've got a problem here, like on a sine wave or even a tangent or cosine. So they fail. They're actually what we call not 1 to 1, but they fail the horizontal line test. So in order for us to discuss their inverses, we restrict their domains, and it's been restricted on your graphing calculator as well. So we'll talk about what your graphing calculator does when you work with your inverse functions. So the first one I've got graphed up here is the function y equals sine x. And as it stands, I can't talk about its inverse because its inverse wouldn't be a function. But when I cut it off at, notice I can't go from 0 to pi because I'm still going to fail the horizontal line test. But when I cut it off from here to here, so let's go shade that really darkly. When I cut that off, then I can talk about its inverse. Its domain is negative pi over 2 to pi over 2. And the range for the sine function, the lowest it gets is negative 1. And the highest it gets is 1. And so when you look at the graph of arcsine or sine inverse, they're the same thing. When you look over here at the graph of its inverse function, you'll notice that the domain and range swap, which makes sense because inverse functions swap out x's with y's. So all the x's become all the y's, and all the y's become all the x's. So we get a domain and a range swap out on our inverse functions. So what we're going to do is talk about two other big ones. The cosine function. Let's go draw it. Cosine of 0 is 1. And at pi over 2, it's 0. And at pi, it's negative 1. And it just kind of goes along like this. And I am going to restrict its domain. Do you think it's going to have the exact same domain restriction as sine did? Let's write this on here. Y equals cosine x. Will it have this exact same domain restriction? What do you think? It won't. The reason is because, again, it's where this hump is occurring here. I can't be from negative pi over 2 to pi over 2. This is the most logical domain restriction for cosine. So go shade that in. When your calculator evaluates cosine inverse, it will always give you an answer from 0 to pi. All right, let's talk about tangent and what its domain restriction would be. Tangent of 0 is 0 because it's sine 0 over cosine 0, or 0 over 1. It's got asymptotes at pi over 2 and negative pi over 2. And hopefully remember what it looks like. Let's go throw that on there. And it's periodic. It runs like that. So the most obvious domain restriction for tangent would be between which two? What do you think? You can go ahead and answer me. Katie. Yeah. You're cleared for takeoff. What's your vector, Victor? Roger, over. Just kidding. Sorry. Bye, banana. Sorry about that. Anyone listening to this? Aaron, sorry. I do this for Aaron Dwyer sometimes. Anyway. Sorry, Aaron. Somebody walked in the room. Anyway, where am I? So right here would be the most obvious domain restriction. It'll have the same one that our sine function had. So on the next page, what I've got going for you is just in case we are rusty with our, oops, wasn't there a unit circle on the next page? Or where is it? Oh, it's on the third one. There, go here for a minute. I hate it when people have to look at this. But just in case you're a little rusty on it, here it is. You will not have one for a test or the AP test or anything. But let's go add a little something something to it. Go like this and squiggle all the way on down here. Go like that. And then, because you're not color coded, go on the inside and go like that. The red one is the domain, or the range actually, of sine inverse and tangent inverse. Those ones go from negative pi over 2 to pi over 2. The dotted is what pops out when you do cosine inverse. It's got a little different one, just so you can kind of tell. So for example, what I mean by that is if I asked you what's cosine, let's say sine inverse 1/2, it happens here and it happens here. But your calculator will only give this angle. It won't give the other one because it's been programmed just to give the one that's in the domain. So we'll practice that on the next page, which is actually back page. All right, so notation for the inverse trig functions are obviously what you first learn in geometry. They look like this. And I'm just going to do the main ones here. However, you can kind of see why that might be a problem once you hit calculus, because that -1, it looks an awful lot like an exponent, so that you might be thinking, oh, the derivative, just bring the -1 out front and drop. That's not an exponent, and it can get really confused with this. So I don't know what notation you use most in pre-calc, but in calculus, it goes almost always arc sine, just to not confuse that as a negative exponent or as a power, because we have so many rules that use our powers. So let's go take a look at this. When we say that y equals arc sine of x, really what that means is that the sine of y is equal to x. You might say, I don't get that. So let's go kind of back to the first pair of inverse functions you ever learned. If you take x and add 2 and subtract 2, you're right back to x, right? Then the second set we ever learned was multiplication and division. If you take x and you multiply it by 3 and then divide by 3, you're right back to x. They're called inverse operations. Then we learned that if you take x and you square it and you square root it, you're right back to x. We had another set. And then we had some that were like e to the ln x. Well, those undo each other. Or ln e to the x. They undo each other. The derivative of the integral, what does that do? Undoes each other. Well, that's what happens with your trig functions. When you do the sine, go ahead and write this, of both sides, sine of arc sine undoes each other because they are inverse operations. So really what I'm doing is taking the sine of both sides. So when you see this, that pi sixths is arc sine 1/2, really what that means is the sine of pi over 6 is equal to sine arc sine, or sine sine inverse. Boom. Now, you should actually have a deeper understanding so you don't have to do that all the time. For example, if I were to say what's arc sine 1, you should be able to think that out. I'm asking you the sine of what angle equals 1. So let's talk about that. If I were to say what's arc sine of 1, I want to know what angle has a sine of 1. What's the answer? Pi halves. Yeah, you should be able to think it out. But in the event that you can't, this is what I would suggest you do. If it messes with your head, the inverse function poops out an angle. When I use cosine and I go to my calculator, I go like cosine 30 degrees or cosine pi over 4. I input an angle. But when I do arc sine, the output's an angle. So this is what I know, is that I want to know what angle has a sine of -1/2. But let's go like this. Theta equals arc sine -1/2. And let's just do it. How do I undo arc sine? What's its inverse operation? Sine, yeah. So if you want to think of it more algebraically, you can just say, well, I'm going to apply arcsine's inverse function. The sine of arcsine undoes it. So it falls out naturally. You should kind of understand the deeper definition of it. So what I'm looking for on my unit circle is what angle has a sine of negative a half. Sine is y, so I know I'm below the x-axis. But because of my domain restriction, I am going to be outputting the angle over here. There's actually two angles, but the one that your calculator will give you and that is more commonly used is this one over here, where the y value is a half. So what angle is that? Which one? Yes, but if you call it 11 pi sixths, you're actually outside the domain. It's right. But really, what do you think your calculator is going to give you? Let's go do it on your calculator. Watch. Go ahead on your calculator and just do, or watch mine on the TV, do second sine, and then do negative 0.5. And you'll notice it doesn't give you 11 pi over 6. Okay? Look, it gives me negative point. Here's 11 pi 6. So I'm totally in agreement with you, but those are very different. What is it giving me? Actually, the decimal version of negative what? Go ahead, Mikey. Of negative pi sixths. Yeah, oops, sorry, I forgot to hit the negative in front of that. But this is actually negative pi over 6, and that's technically really what you're supposed to put. Will you get it wrong if you put 11 pi over 6? Probably not, but that's not how it would ever be listed. There's actually another angle with the exact same sign. And you should know what it is. What is it? It's not the one your calculator will give you because your calculator has only been programmed to be in the domain. But what angle is that over there on the left, right, from here to here? It would be 6 pi over 6 plus 1 more. So that'd be 7 pi sixths. All right? Let's go take a look at the next one. Let's just do it with common sense. What angle has a cosine of 0? What's the answer? No. Pi over 2. Yeah, what angle has a cosine or x value of 0 and it's in cosine's domain? So that would be pi halves. Again, it's always fair to say I'm going to let theta or y or something equal. Let's go take this one the longer way. So let's say y is equal to arctan root 3. I don't want arctan. Let's undo it. Like I don't want a square root. Well, then I'll square it. I don't want to divide by 3. Well, then I'll multiply. I don't want to arctan. Well, then I'm going to tan. There we go. Now, you might say, I don't know that. Here's what you need to do. You have to create. Don't memorize things. You're going to think it out. First of all, tangent is restricted to this spot for its output, right? It's positive, so now I know I'm going to be in here. So I'm narrowing down my possibilities. I know for sure it's not pi fourths, because at pi fourths, sine and cosine are the same. So I've narrowed it down to 50-50. It's either pi over 6 or pi over 3. So go draw it. And here's how we decide. We've got to think of what their points are. And let's suppose Miss Tori forgot. She'll use common sense because she knows one of them's root 3 over 2 and one's a half, correct? You can common sense it out. This is root 3 over 2. It's very stretched out, right? This one would have to be closer in or at a half. So you can just kind of think it out. No memorizing whatsoever. If you memorize, great, or if you have one of the little tricks, that's fine. You need to decide which one of those has a tangent of root 3. How do you get tangent? Sine over cosine, or y over x. So we got to test both of them. I only have 2. I'll just test this one first. Right here, let's try root 3 over 2 sine over cosine. These will cancel when you multiply by a reciprocal, and I found it. So this one would be pi thirds, for sure. You should get stuck on letter D because it's not on the unit circle, which means you have to go to your calculator. You just have to go second sine or sine inverse 0.3. Somebody go do that for me. Go do sine inverse 0.3 so I can stick that on there. I'm going to steal your calculator. Let's do second sine 0.3, and we get about 0.305 if we round it. So on the bottom, I put a little note to you, right? For angles around the unit circle, you should be able to think them out. So if you're seeing zeros, ones, root 2's over 2's, root 3's over 2's, all that good stuff, think it out. But for decimally ones like this, use your calculator. So let's mosey along here. And this is a lot of pre-calc, but it's good stuff. So keep in mind that these are all inverse functions. So cosine inverse of cosine is x, sine inverse of sine is x, and tan inverse of tangent is x. And that's how they help you solve for ones like example number 2. So let's go take a look at example number 2. If that 2x minus 3 was trapped under a root, pretend, don't write this in your notes. If it was trapped under a root, what would you do? Square it, right? If it was squared, what would you do? Root it. It's arctangent. So what are you going to do? Tan it. Yeah, let's go do it. So we will take the tangent of the left. It's all very logical, and it's got to equal the tangent of the right. Well, and you can do that in your head. I know I just wrote that one out. But tan and arctan undo each other. So I've got 2x minus 3, and we should know tan pi fourths without any kind of a hassle, right? Booth, what's tan pi fourths? 1, right? And then it just becomes a two-step algebra equation. Add 3, divide by 2, and I'm done. So I'm not going to do any more of those solvings. If in your homework it's arc cosine something, well then you take cosine. You do the inverse function just like you always have. I did it twice here without batting an eye. I added 3 divided by 2. It's the same process, just like on steroids. All right. This part, tune in if you tuned out, because I am covering about a full chapter of pre-calc right now. They just tested on this in pre-calc last week, I think. It's a whole chapter, and we're doing it in 23 minutes. Yes. Here we go. So, watch. Let's go do part A. Y is equal to arc sine x. Don't like arc sine, so guess what I'm going to do? What am I going to do? Sine them. Yep, I'm going to sine the left. And what I know is that the sine of y is equal to the sine of arcsine, or just x. Right? I am now going to go draw myself a little triangle. It's all very geometry. My angle, which in this case is called y, has a sine of x, and let's put that as x over 1. So you got to remember one of your favorite acronyms from geometry. What acronym relates your sine, cosine, and tangent sides? SOHCAHTOA, yes. So really what this is it's telling me my opposite and my hypotenuse. So what I know is this is x and this is 1. Why is that helpful? Because they told me to find cosine of y. So if sine is opposite over hypotenuse, dig into the depths of your memory. Cosine is what? Adjacent. Yeah, so I need to do adjacent over hypotenuse. Well, they didn't give it to me. Well, who's my best friend in right triangle world? Pythagoras, right? You could probably do the Pythagorean theorem in your head. I honestly don't care if you do, but you are solving that for A. So it would be the square root of 1 minus x squared. And I honestly don't need you to show me your Pythagorean theorem work. I'm good with you doing that in your head. So let's go take a look. Cosine y would be adjacent, which is square root of 1 minus x squared, over hypotenuse, which is just 1. And it's done. Easy peasy mac and cheesy. So let's go look at letter B. All right. So same, and I didn't give you a whole lot of room. You might want to put it down here or something. But for letter B, I've got y equaling secant inverse. All right, hate that. It's ugly. I didn't even like to write it. So I'm going to get rid of it, right? What am I going to do to both sides? Secant it. Yep, so let's go do that. So I'm going to secant the left. When I secant, arc secant, it's like I'm squaring a square root. or deriving an integral, they undo each other. I'm at root 5 halves. Then I get to go draw myself a little pretty picture that sets this up, Ben. So I go put a y here. And let's talk about this. If cosine is a over h, what's secant? H over a, exactly. It's the reciprocal. So this is actually equal to, awesome, trig remembering over there, it's equal to hypotenuse over adjacent. So let's go see what I was asked to find. Because again, you want to get it as squared away as you can before you start. I'm supposed to get the tangent of the angle. Well, tangent is opposite over adjacent. So let's go take a look and find that. Go ahead and find that opposite side for me. Yep. So opposite side would be, use a Pythagorean theorem in your head, do it as fast as you can. What you got for it? Quick and easy. What's the opposite side? Got it for me quick? 2 squared plus equals, that's for you, dear. He's right. Do you need him? All right, yep, you're right. It'd be a 1. So let's go set this up. Opposite over adjacent, done. So just a lot of pre-calc review, but it's kind of a breath of fresh air after doing so much calculus. So let's go 2 more and we are almost done. First of all, it says evaluate the cotangent of all this stuff, which this normally is kind of tricky, but what I want you to do is go like this, because you can only take the cotangent of an angle. So go put theta right there so you understand that inside of those parentheses is some unknown angle. And this is what you know. You know that theta is equal to, and again, I don't really like that cosine inverse, but I'm going to use it, is equal to cosine inverse of 2/5. That's what you know. I'm just defining it as my angle in there. So to undo that, oh yeah, negative, and that's super important, so thank you. I'm going to undo this. So I know that the cosine of that angle has to be negative 2/5. Well, here's what else I know. Cosine is adjacent over hypotenuse. Now this should kind of be bugging you a little bit. Drawing a triangle for this, why should that kind of bother you? Because of the negative. Well, this is really what you're doing when you're drawing that triangle. Let's go lay it out on the unit circle. First of all, for cosine to be negative, it has to be in this quadrant or this one. Due to domain restrictions, I know it's over here. So let's go draw that angle over there. We'll call it theta. So really what this is telling me is that my adjacent's just going this way. It's no big deal. So that's actually a length of 2 or negative 2 on the x-axis. You can put a 2 or a negative 2. It doesn't really matter because what are you going to do with it? Square it, right? But you should probably put the sign on there just because of the other trig ratios. So go ahead and figure out what this missing opposite side is. I don't like to call it O because it looks like a 0. I'm going to put a question mark. So you guys go find that. You should do it in your head, right? That squared plus 4 equals 25. That squared's 21. What's that squared? What would this be over here? We're at 21. So let's go see what I'm supposed to find. Cotangent. So let's go set it up. Cotangent theta would equal. Well, if tangent's AO, right? What's cotangent? OA. AO. AO. But we're OA because we're doing the reciprocal. So let's go have at it. Opposite would be, oh, I did it. It's AO. Sorry. TOA, cotangent is AO. So it'd be adjacent over hypotenuse. Do you think you're required to rationalize that denominator? Never. It's not a skill that would make it look any better. Historically, it was done so you weren't dividing by a big ugly decimal, but we don't care because we have good calculators, so go ahead and circle it and don't waste your time. So why don't you go try doing that last one real quick. I'm going to pause this while you try. All right, we're back. All right, so we need to take the sine of an angle. All I know is the tan inverse of that angle. So I know my angle has a tangent of what? 3x. I mean, I could even think it out like that. If I'm going to be more formal, I'll define this as theta. I could say arctan, but sometimes I think in the whole writing it out like dun dun dun, you lose track of what you're doing. I need to take a sine of an angle. My angle has to have a tangent of 3x. But let's go take a look. When I tan both sides, I'll get theta equals tan 3x, which is really 3x over 1 as a ratio. At this point, I go draw an angle. I go TOA, and I go opposite over adjacent. Are you good so far? I don't want that. I want to know the sine of that unknown angle, and sine is opposite over hypotenuse. So let's go take a look at what I'm missing here. I've got opposite, which is 3x. I'm missing the hypotenuse, maybe even just call it c, and I do a little Pythagorean theorem. 1 squared plus 3x squared equals c squared. So c is going to be the square root of 9x squared plus 1, or 3x squared quantity squared plus 1. How many of you had that one right for the most part? Or I cut you off a little early, but good. Take good notes, by the way, because you can use them on everything. We are not testing on this stuff, just a problem set and some homework. So your notes are fair game. So first of all, let's go graph these. So I think I already have them loaded on my calculator, so you can just watch mine, okay? You don't need to take out your calculator. When you graph this one in Y1, let's just go like this, and this one in Y2, this is what you'll see. All right, watch my TV. They both lie on each other. So if I'm going to even hit second quit and see if it'll graph it from the get-go. It won't. But the first one actually goes like this, and then like this. And then when I run the second one, it falls right on top of it. They're identical functions. So for part B, when it says to prove, that's the only part I really want to do, that those are equal functions, we are going to start. What am I going to call that inverse trig function? What am I going to call the inverse trig function? That's theta. That's some angle. Yep. Some angle I need to take the tangent of is defined as arc cosine. So let's go take a look. To undo that, I will say the cosine has to be x over 2, and you can jump right here if you really get it. Right here, what do I go do? Draw myself a pretty little picture, exactly. I go back to geometry and what I was taught about right triangle trigonometry. That cosine is adjacent over hypotenuse. So I go adjacent over hypotenuse, and I lay it all out on my right triangle. And then I go back and I figure out, well, what am I trying to do? I'm trying to take the tangent of theta. Well, tangent is opposite over adjacent. Don't have the opposite, but let's call it, I might as well just call it y. I've got x squared plus y squared equals c squared. So to figure out y, I'd subtract and take a root. Just some Pythagorean theorem. I don't need to talk you through that, right? So I'm ready to set up my ratio. My opposite would be square root 4 minus x squared, and my adjacent is x. It's a direct match to that same function that graphed right on top of it. So it's kind of cool. Are we good? Can you rank yourselves on a scale of 1 to 5 with a month's worth of trig in 20 minutes? Cruising through, lots of 4s. All right, and then once you do the homework, you'll be a 5. Let's go pretend we're starting this one. Pretend that was the square root of something. What would you do right away? Square it, right? So what do you think I'm going to start by doing? What would be your guess? Go ahead, Olivia. How would I start that? I want to figure out what x is. Cosine, yeah, let's do it. Why not? Or I could secant both sides, but cosine's friendlier and it's on the left, and I like to read from left to right. So I'm going to undo the function on the left, and I'll do the same function to the right. It looks really weird, but these undo each other. So I've got x is going to be defined as cosine of arc secant x. And this is where it gets a little weird and you kind of have to have your ducks in a row. X is the cosine of an angle. Let's go write that down. That angle is that. So now let me get my hands on that angle. What do you think I'm going to do to both sides? Secant it. Yep, just kind of going in a circle here, but it's eventually, I want everything in terms of x, and I want to get these trig functions out of here because it says I'm supposed to tell you what x is. Well, I got to get all the trig stuff out. So I started off getting the arc sine off. Now I'm going to get the arc secant off by saying the secant of theta is equal to x. Now, if cosine is a over h, what's secant? H over a. All right, and I could go draw a little picture, but I could actually outsmart it. Because if secant is x, what's cosine? 1 over x. Yeah, I don't really need to go through this is following procedure and being kind of monkey see, monkey do, like LaRue always drew a picture here, so I'm going to. Well, you'll get it right, because this is h over a, so you'll go h over a, but cosine is a over h, so I just kind of went, that's called circular reasoning. I could have just said, I know that cosine theta is 1 over x. So now this is a kind of a weird question, but I was supposed to solve this for what? X. I've got x on the left, and I just got the whole right-hand side cosine theta to be 1 over x. Let's put 3 bars under there so you can see it. What's x? What do you think? 1, yeah, or -1. Exactly, perfect. That's a proportion. That's just x squared is equal to 1. When you cross multiply, x is plus or minus 1. So a lot of this was just for fun because it was all pre-calc. But eventually what we're going to be starting tomorrow is taking the derivatives, and I thought it's good just to have a good understanding of all these before we start. Your assignment, we're going to take this off. For now, it's 5 through 39 odd. But when did I say it's due? Did I tell you guys? It's all due Thursday. Yeah, all the bookwork. I'll give you a little bit more bookwork tomorrow. Tonight's homework, you can ignore this. We'll have all day Wednesday to actually work on bookwork, so I would ignore that. Tonight's homework is to do test corrections.